Today's stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Landon Fachinacci, and let's write some code together, shall we? What we have on the menu today is to build some auxiliary tools, some helpers, some debug tools for the library that we are creating together. It's a library to help us develop JS effects, the real-time audio processors in REAPER. We are focusing on the user interface part of things, and we have been working for a while in this component called the Waveform Display. This is what it looks like right now, and as I speak, it's drawing the waveform. The problem that I see on this display is that it jumps around ever so slightly, and I'm trying to figure out why that could be, why that's happening. I have a theory. The theory is that the UI thread, the user interface thread, the thing that is actually drawing this, has to do too much work. And because it has to do too much work, it sometimes drops frames, and that's why it jumps around. I think I know why it may be doing too much work and how we could relocate that work, and I have some ideas on how to go about that. But before I even start exploring all of this, I want to make sure that it is the case that the issue is that this is doing too much work on the user interface thread. So the first thing I'm going to do is build this component that it will show me the frame rate that this is running at. Of course, I can set the frame rate to whatever value I want. In this case, I set the frame rate to 60 frames per second, but is REAPER rendering this 60 times a second? Well, probably not. It probably drops some frames, especially when there are more things running on my machine, like I am streaming. There is the audio processing part of this, which of course, right now is not doing anything, but in a real effect, it will do more than just show the waveforms. It will also show what the effect is doing to the waveforms. So if it is compressing, for instance, if it is a compressor, then it will show the gain reduction by making the waveforms a little bit smaller, that sort of thing. So let's start by building this new component that will show us the frames per second. And I'm going to start by hard coding this into the waveform effect, and then I will pull it out into the library. And of course, I will do it here as opposed to what I usually do, which is to have a dedicated effect for testing things out. But in this case, I specifically am interested in knowing if this effect is dropping frames, so just put the logic right here. So the logic will go like this. My idea is that I am going to count frames. So I'm going to simply count frames like this. To begin with, GFX frames is going to be 0. That's the init block. Then anytime that we run the user interface thread, I will add 1. And also we'll have a frames per second count. It will start as 0, or maybe even start as undefined. That's good. And I guess this frames counter is related to the frames per second, so I will do something like this. Oops, that didn't turn out too good. Now it's better. So the frames per second count starts as undefined, and then we start the counter for the frames, and then we increment the counter for the frames just like that. But we also have to check if a second has elapsed, because we are counting the number of frames not in absolute, but the number of frames per second. So I will have a variable called last second, which will also start as undefined. Then, anytime that the GFX block is called, let's see if this is undefined. I'll have to do some initialization work. So I guess this can start as undefined as well, because I will do initialization work. I might as well initialize this frames variable as well. And this is just time. This is a JS effects function. No. I think it will be near memory stuff. No. Special time functions. There you go. So this returns the current time in seconds, which means that this will be time in seconds. Great. So I will do this to initialize. Then I will add 1, and then I will check if the last second, or maybe not the last second, maybe the last time, or maybe not the last time, but time previous, something like that will do. So if the time previous is not the same as the current time, or maybe I will do something like the current time, and if the previous time is not equal to the current time, it means that a second has elapsed. So in that case, I will update frames per second to be equal to the number of frames that I counted on that second. I will also update the previous to be equal to the current. And I think that does it. Yeah, let's review the code. So we have a bunch of variables that we start as undefined. Then in the GFX block, we check if we are just starting up. Oh, I guess I also need to reset the number of frames here. Okay, so to begin with, the number of frames in that second is 0. The previous time is just set to the current time. Then I will add 1 to the number of frames. I will check what is the current time, and I will check if the current time is different from the last time. All of that given in seconds. So if that is the case, I can update this count, I can reset this, and I can reset that. Perfect. So I could just look at this variable in the debugger, but just for convenience, I will also draw it. I think I have a function called print. And what is the string that I want to print? Well, it is this. In case this line here doesn't make sense to you, well, all that's happening here is I have a number that I want to print as a string, so I'm converting the number into a string. That's the essence of what this line is doing. The way that it's doing it is I am assigning a value to this variable here. This means that a variable is a string. Then I am passing a format string that is just a digit, and then I'm passing this as the value to put in this place. Let me make sure that I got this right. Yeah, it's the string, the format, and then the values, and this is a parameter as an integer. Sounds good. So now I have a string that I can print. What will be the font size? Probably something small. Yeah, let's do extra small. Font style. Let's do bold, because we are doing something small, so it might as well be bold. In terms of letter spacing, let's use something a little bit wider, because I will write FPS and in all caps, so it asks for something a little bit wider. Probably widest will do, because this is so small. I don't know why I'm trying to make this look good. It's a debug thing, but still. So text align, I will align to the left. Or maybe I will align to the right, because the number may grow to the left. And in terms of vertical alignment, I don't really care, but I will align to the top. In terms of text overflow, I want it to be visible. And in terms of color, I will want some kind of dark gray. What is the kind of gray that we are using? We are using warm, and the background color is 900. So I think that the text in 600 will probably, maybe 400. That will probably work. And then the X position can be the same as the Y, which will be a space of 2. And the width and height can be a space of 0, because I don't want any kind of center alignment, so this doesn't come into play. I'll also come here and adjust these arguments. I'm trying to put them on the same line in many places, because I think it looks better. So there you have it. Now let's see if this is printing anything at all. Well, it is printing something, but it doesn't print what I was expecting it to print. Also, I want to have a space and a frames per second situation going on here. Oh, and also I don't want to print when the thing is undefined. So I'll check if it's not undefined. So I think that that big number there is the undefined value. And because this is not going away, I suppose that now that I put this back on the track, we'll never see anything. It's never going to print anything. Yeah, so now we have to dive into here and look at the variables and try to understand why they're not working. This is working all right, but the count of frames is not working. Isn't that something? Oh, because I am checking this variable, and this variable is undefined until the first second passes. So I guess I will do this instead. This should work now. Yeah, now the number of frames is increasing, and yeah, we have a counter here. Excellent. And just by glancing at it, it seems to prove my point. Yeah, this frames per second counter is not a 60. as it should be. So we are dropping frames, and Reaper is not calling our function as often as it should. Now, first of all, this is too big, so I'll make it extra small too. Okay, it's not too bad. Probably could be a little bit smaller, because even the smallest size is about the size of this, which is already kind of big. So maybe we need to revisit our design system. And did I make it bold? I made it bold. So yeah, okay. We did it. We have a frames per second counter. So in about 15 minutes, I did the thing I promised I would in the title of the stream, which is unusual for me. Usually I end up not even doing the thing that I was proposing to do in the title of the stream, because I always get sidetracked and there is a million things that get complicated and weird. But not this time. Here is a counter of frames per second. And now we are going to play around with this to learn more about this system. But first, let's commit what we have. Yeah, not too bad. So, I have a couple things that I want to experiment with. The first is to maybe drop this into another plugin to see if the plugin is not doing anything if we get a steady 60 frames per second. I will duplicate the waveform plugin, and I will call this one frames per second. And then let's see what we have to change. I will want to keep the 60 frames per second thing, so I'll keep that line. Then most of these things can go away. And then I will keep that one. The sample block doesn't have to do anything. Then this has to exist, that has to exist, and all of this can go away. So this is about as simple as it gets. A plugin that doesn't do anything except for showing the number of frames per second. And can that one keep a steady 60 frames per second? Check this out. It can, for the most part. It's not perfect, unfortunately. But I think it is for sure better than this. Maybe not. Yeah, this is keeping a steady 60 frames per second now. As I start speaking, it's going to draw more, and I wonder if that has any influence on the frames per second count. But it doesn't seem to. Before it was jumping around a lot more than it is now. That's weird. Let's come back to this one. Okay, this is clearly more stable. This is better. So there is hope. We are doing too much work on the UI thread, on the waveform display. I think that if we save some work there, we may be able to get better performance. And as I move things around here, I wonder if that affects the reading, because I am doing more things on my graphics. So moving windows around takes more CPU power, GPU power. So I wonder if that has any effect. It seems to have. It seems to drop by 10 frames or 15 consistently. And yeah, there is hope that we can make this slightly smoother if we can save some work on the UI thread. Oh, and Bo is back. Hello, Bo. You're here. I am okay. How is your code, you ask me? It's better. I am much better. That's why I'm back to streaming. I am back. I recovered. It wasn't as bad for my wife and the baby, but for me it was pretty bad. I had a fever and everything. But I'm back. I'm recovered. How about you? How are you doing, Bo? All right, so this is proving something. I also want to experiment with something else. What happens if I drop the frame rate to 30 frames per second by just removing these lines? Because 30 is supposed to be the default. What happens if I do that? Can I get a steady 30 frames per second? And I'm not too worried about the fact that sometimes it jumps to 31 or sometimes it may jump to 29. That's just because we are counting the number of frames that happened in 1 second. And it may be the case that some seconds have 31 frames and then the next second has 29. But overall, it's 30 frames per second, if you know what I mean. Oh, I don't know if I got the flu, if I had COVID. I didn't get tested or anything, so I don't know what I had. I just know that I'm better now. Right, so this is much better, much better. Let's look at the waveform display. And this is also much better. Now, it's keeping the 30 frames per second, which is much better, but it's also jumping around more. At least I think it is. So there is some problem in the logic of how we are doing this. So maybe what we are learning is that, at least on my computer, REAPER cannot handle a steady 60 frames per second, but it can handle a steady 30 frames per second just fine. Do you think that it's better to have 60 frames per second and drop some frames, or to be at 30 frames per second and be consistent? I think it's better to be consistent at 30 frames per second. Yeah, that's what I think. But as you can see, I'm still not perfect, just better. Right, so maybe one decision we can take is that we are going to run at 30 frames per second. Hopefully that will be smoother. Another decision is that there is some timing situation that we could improve here on the waveform display, maybe. And definitely we want to extract this whole frames per second counter into the library. So let's go ahead and do that, the extraction. So how is that going to work? Well, I'll say that this component can come right here. And I'll call this one the frames per second counter or display, frames per second display. And we'll define these variables over there. And then we will define a function. And maybe we will add underscores to the variable names. Yeah, let's do that. So in the init block, there was this. Let's add underscores, because now we are putting things into the library. Everything in the library is namespaced with underscore. So that's what we are doing. And I think that I will rename this variable because I want this to be the name of the function. Oh, and Jerome is here. First time catching a live stream of you and or Arya. Thanks for sharing. Thanks for being here. It's great to have you here. I hope you enjoy. let's find all the occurrences of this variable and let's find how we can rename the variable. I'll call this the counter, the frames per second counter. And this I will call counter string, just like that. So then let's restart this process of extraction. And I think that I am using uppercase, so I'll do that here as well. Frames per second display. Maybe I'll just have this as frames per second, and I will have maybe not counter, but value. How about value? Oh, and look at that. Bops is here. Hello. Long time no see. It's great to have you all here. Yeah, I'll rename all occurrences of counter to value. Whatever. And then I will define a function called frames per second. And do I have the GFX namespace elsewhere? It doesn't seem like I do. Like on the waveform display, I don't have that. So I guess I will just remove all of these namespaces. Whoops. Better. And naturally from here as well. Then I should be able to just copy and paste this into the body of the function. And then let's review the frames per second value, frames in the previous time. They'll start as undefined. Then if the thing is undefined, set it to 0, get the current time. Oh, that's silly, isn't it? For me to start with undefined and then check if it is undefined and then set. I could just simply set there. Then I increase this, check the time. I guess I was doing it this way because strictly speaking, this is more correct. But in practice, the time it takes between the library being loaded and this happening is negligible, so it should be okay. This has changed. It should be dot value. And maybe I should be getting some of these values as arguments. Maybe, but not. I don't think I will. Let's just see what I can make to make this generic enough that it won't care about the values. I guess I'll just draw this in red so it will stand out, because this gray may not work depending on your background that you have on your effect. So I just turn this into red and everything else should work. So I don't need to receive anything as argument. So I think that does it for me. Yeah, let's check if this works. So the way you use this is you don't need to do any work in the initialization. This is something that you should always have, so I'll have it. And this initializes the design system, this sets the background color, and then this. And this is how you use it. And it works. Maybe I'll tweak the color a little bit. I think that maybe the red 500 will work better. And this should be good. A very clear readout of your frames per second. Bob says, yeah, I just did a short scoring project a couple weeks ago, but did it in Studio One. Oh, interesting. How do you like Studio One? I know it exists, but I have never used it. So what are the pros and cons when compared to what I know, which is Reaper? Right. Okay, so we learned stuff. We extracted stuff. Stuff is looking good. Now let's go to the next part of what I planned for this stream. It has nothing to do with the frames per second count, but it does have to do with something that we have here on the waveform display. So when this is still using the old code. Let me take a moment to update this. So all of this can go away. And then all of this can be turned into frames per second. Ideally as the last thing, so it prints on top. Right, so the issue at hand is when I go to some other plugin, or even if I just close this window so that it's no longer rendering the waveform, and then when I get back there, it needs to reset, as it does. We already wrote code for some of this, but I think I found a smarter way of going about this code that may make things a little bit faster, and I also think that we need the converse. So let me explain. What we currently have is on the detection that we have is we can detect whether the GFX block, the user interface block, is no longer running. And then we can detect that's useful in the audio processing part of things so that we don't have to keep pushing samples into the circular buffer that will eventually be displayed on the screen. So we can save some work on the audio thread when we are not displaying the waveform. I think that we may be even able to see that. So over here we have a 0.1% CPU use when the plugin is open, but when the user interface is closed, you can see that this number goes down to 0 because now the audio thread is no longer doing any work at all. This waveform plugin doesn't process the audio in any way, and it's not pushing into the circular buffer because it's not displaying the waveform. So we have some way to detect that the user interface is not showing. This is useful because we can save some work on the audio thread, and because when I go back into the effect, I need to reset things. I need to erase the waveform that was there. Keep in mind that there is some waveform on the screen right now, and as I move to another plugin, there is no JS Effects way of saying, okay, I am about to go out of the screen. Please run this block of code so that I can erase stuff. It doesn't exist. The JS Effects doesn't have any kind of function like that. So what I do instead is I check when I'm rendering again. So when I go back into the plugin, I check, oh, it has been some time since I ran. I might as well erase the whole thing. And this is the code that we have. So that's one direction of this situation. The direction of I am on the user interface thread and I'm interested in knowing if I am open or not, or if I just opened. But there is also the opposite. Sometimes your process is bypassed. So the plugin is not really processing the audio, but it's still doing the video. You can see that this number here, the frames per second, is changing. And that's because the user interface thread is running. The waveform stopped because the audio thread is no longer pushing samples into the circular buffer, so it just stopped the drawing. But the effect is bypassed, but it is still, the user interface is running. So there are these two threads, the audio thread and the user interface thread. And in some situations, only one of the two is running. When you have the plugin running, processing audio, and the user interface open, both threads are running. If you bypass the effect, the audio thread is no longer running, but the user interface keeps running. And if you have processing going on, but you go to another plugin, then the user interface thread is not running, but the audio processing is running. That's the other direction. And I think that in our library, we should have ways of detecting either direction because they're both useful. As I mentioned, when you have the process going, but you go to another plugin, you can save some CPU. Also, when you get back into the plugin, you may want to reset things. But also, if you are bypassed, you may want to do something special. Like in this case, you may want to gray out the waveform to show that it's not really running in real time. It's not collecting new samples. Or you may want to have some kind of indication in the plugin that it's bypassed, like a blinking light or whatever. So it can be useful to know whether the user interface thread is running, but the audio thread is not. So that's the story. That's the thing that we are about to build. We are going to build detectors for both of these things. And one of these we already built a detector for, but I think we can be smarter and go about this differently. In fact, I think that there is a very good use case here for the detection of bypassing. If we are bypassing, I think that the waveform should erase, because otherwise it may seem like things that are happening in succession here are not really happening in succession in real life. So that can be misleading when you're using the plugin. So I think it makes sense for me to erase the screen as you bypass. So that's what we're going to do. But first, let me read what you all are saying. Cool, are you happy with the results? In video, you can set frames per second, which I read from the video info. Then I get a second grid to seconds. Then I can see transitions in video by seconds and mark the transitions. Not precise, but close enough to me there. I know your setting up a quick code to solve these things in REAPER. I don't really understand what you're saying. Can you explain further? Yeah, I don't think I understand that. When you say in video, do you mean the video processors? Because this is related, but not quite the same as the video processors. Right, so let's get in there and maybe let's start with the simpler thing, which is to just detect if the effect is bypassed. We'll detect if this bypass button is, I guess, if this checkbox is unmarked, if the effect is bypassed. That's what we are going to do now. We're going to detect whether this is the case. How do we do that? Well, I guess I will do this in a separate effect. And then we will extract this into the library once we have it working. So we'll do something on the sample block, and we'll do something on the GFX block. Our goal is to detect whether the sample block is even running. If the effect is bypassed, the sample block is not running. So this is how this is going to go. I'm going to set a variable here that I'm going to call bypassed, and I'm going to say that this is true. Over here, I'll have bypassed is equal to false. And then I guess I'm just going to check if the thing is bypassed. Then I am going to maybe just GFX rect. Something really simple, just drawing a rectangle at position 10, 10 with dimensions of 100, 100. So when the effect is bypassed, we should see a big red rectangle on the screen. So the effect is running, we don't see any rectangles, and as I bypass, you see the rectangle there. And I bring it back, and it does not come back. It should come back. Why is it not coming back? Am I doing something silly? Oh, bypass this flipping between 0 and 1. Interesting. Let me explain the logic, why I think it should work, potential reasons why it's not working. The logic goes like this. The GFX block is going to set bypass to true. But the sample block is going to say, no, 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 I am not bypassed, and set it back to false. The idea is that the GFX block runs a lot less often. It runs 30 times a second, 60 if you're pushing it. But the sample block is running 40,000 times a second. It's running much more often. So if the effect is not bypassed, then this is going to run a lot more often, which means it will set the bypass back to false. So it becomes a race condition that I'm kind of exploiting here. The race condition is, this is trying to say this is bypassed, but this is negating that. And if we stop processing, if we bypass the effect, we stop processing, then this is going to stop counteracting this line. And another condition that I am relying on is the fact that between two consecutive runs of GFX, there will be at least one run of sample if the plugin is running. And I guess this is a safe guarantee because the sample block runs a lot more often, by orders of magnitude more often. So it should be the case that this always runs between two consecutive runs of this. That's the logic, that's the intent. Why is it not working? I don't really know. So here's something. Instead of just setting it to red, I will set it to a color that changes over time. I just want to make sure that this is actually drawing something. And it is drawing. It's always drawing a new square. Okay, good. And if I bypass, is it going to keep changing colors? It doesn't seem to. So maybe that's just because I drew it once and never reset the screen. But I thought that the background color situation had the effect of resetting the screen. Yeah, we are using GFX clear here. So it should not be keeping this. If I do that, then it's going to keep changing the color of the square, but that's very odd. Yeah, it's very odd, but whatever. I'll just maybe do GFX reset of 0. Is that gonna help? It doesn't seem to be helping. How about I just draw a big black rectangle covering the whole screen, which is what the background color was supposed to do. It was supposed to do this. Is it doing that? Weird. I don't know why that was necessary. But it seems like we got this. So now I no longer need to do this trick. And I think we got our bypass detector. Great, we got it. If you watch a video, you see frames in seconds. Let us know how it's going. No, oops. If you watch a video, you see frames in seconds. I'm sorry, I don't know what you mean. Right, okay, this is working. Let's extract this into the library. So I will need something in the sample block, and I will need something in the GFX block, and this is a necessity. There is no way around this. There is no way around it. Not that I know of anyway. We always have to run some code in the sample block to detect whether the sample block is even running at all. Now, we could do this on the block, which could save a little bit of work. I think that this will work just the same if I put it on the block. Let's try. Yeah. Now, weirdly enough, it's no longer drawing the... I guess it's because I don't have a sample block. It's not drawing the meters around my plugin, but never mind that. This is working. So I guess I have to have access to the audio thread, either on the sample block or on the block. It is just setting one variable, so it's not a big deal if I do it on the sample block. I think I might as well do it on the sample block. And we'll need some sort of situation that goes like this. Some sort of situation that will be called on every sample. We need a hook into the sample block from the library. We need to be able to run some code in the library in that context. This is not the first time we encountered this, and I think we will encounter this more often. So yeah, let's just bite the bullet and do it this way. And I am hesitating to do this because now the users of the library will need to do something like this, which is not ideal. And it's a necessity here. It seems to be a necessity there as well. So at least there is a precedent, but I don't love it. It is what it is. Right, and since we have to do it, let's just do it on the block to save ourselves a little bit of computation. So where do we do this? I for sure don't want to have anything related to the GFX block in there, because many of the GFX block functions are not even available on the audio thread. So I want to do it before the design system. And I think it's hard for me to write an automated test for this, so I'll put it after the tests. But I don't know, I may need to revisit this. I think I'll do it on the block. And do I want to call it bypassed, or do I want to call it like the opposite, running, so to speak? Yeah, I think I'll call this the opposite of bypassed. I will reverse the logic. So maybe is processing audio. That's very explicit. And then on the GFX callback, I simply have to do this. And I will call this is processing audio false. And then let's see if this works. On the block, I will have to call the callback. And then over here, I might as well not do that. And then set and rect. Oh, I think I understand why this was not working before. If you just reset the color and you don't draw anything, then it keeps the old frame buffer. And in the code, the way it was only drawing the red rectangle if the thing... It was only drawing the red rectangle if the thing was bypassed, which means that it was not drawing anything at all. Yeah, all right, okay. I can resort to going back to the background color, and the way I can do this is I will always draw a rectangle, so it will always refresh the screen, but I will check if the audio is running or not. So let's see, is processing audio. Or maybe is processing audio could be sample running. Yeah, I think that this is good. Then it will match the GFX running that we'll have later on. And then we can set the color. If the sample block is running, then we'll have a blue color. Otherwise, we'll have red. All right, let's see. The bypass detector. The bypass detector is not working. Oh no. Why would that be? And it's kind of weird that I do this on the block while I'm calling this sample, but I'm just trying to save some work. So I think it should be all right. And oh, this is happening because this is running as the first line right here. And then it will be wrong there. So maybe we want this to be the last thing that happens. No, I don't want to have another callback here at the end. Something like... No, let's not have that. Instead, let's just assign a separate variable. I know it's kind of ugly to have something like this, but that's what we'll have. And this is flag a good name for this? I guess. Sample running flag, sample running flag, sample running flag. Okay. Now it should be working. Okay, it's blue, and it's red, and it's blue, and it's red. Yay, it works. Great. How about we use this on the waveform display real quick, because I said that I wanted to erase, let's erase. I could gray out the waveform when you bypass, but I think I will just erase it because graying things out on the waveform display is complicated. We are drawing to an off-screen image and it gets weird. So I'll just detect on waveform draw. If the GFX reset, or if it's not the case, the GFX, the sample running. Did I get it right? Yep. Then reset. All right, let's try. Waveform. It is not drawing. Oh, I guess. No, this should be right. Let's remove this because this is apparently the issue. Let's check back. Okay, it is working. And if it's not the case that the sample is running. Why would that be wrong? You know what? Sample running. 0. Why is it bypassed? Oh, because I forgot to add the block. See, that's why I didn't want to have that there. Okay, block. All right. If I am forgetting it, I'm sure that the people using the library will forget it as well, but such is life. Okay, so when I bypass the plugin, it stops the waveform display, and then when I re-enable the plugin, it gets back in there. Then, as I go to a different plugin, I'm not bypassing, but that also resets the waveform display. This resets the waveform display. Great, we are back in business. All right, so let's have a moment to take a step back, look at how this is working again, and how we can adapt it to do the other direction. So the direction we just implemented is to check on the GFX block whether the sample block is running. That's to check if the effect is bypassed. But we are also interested in, from the sample block, detect if the GFX block is running. And that's to save some work, just like this, to save some work in the sample block so that we don't have to push the waveforms or push the samples into the waveform in the sample block, thus saving some CPU like I showed before. So this 0.1% CPU goes away as I am not doing anything on the display of the waveforms. Great. So how is the thing that we just implemented working, and how is the other thing working? Let's compare the two implementations. The implementation of the thing we just did is on the GFX block, we are always trying to say, okay, the GFX block thinks that, or it's challenging, I guess that's a good way of putting it. The GFX block is challenging the audio thread. It's saying, I don't think that you are running. Are you running? Like it's poking the audio thread and asking, are you running, guy? By saying this line, it's poking the audio thread and trying to assert whether it's running or not. And then the audio thread has to respond saying, yeah, I'm running. Stop asking, yeah, I'm running. Yeah, I'm running. Yeah, I'm still running. Until it isn't. And then it doesn't respond the challenge. That's how this works. But the other implementation of the other way around, of the GFX block trying to see if the other way around. From the audio thread to see if the UI thread is running, we are doing something different. We are looking at the time, and in essence, it's similar. We're just looking at the time and we are storing the time and everything. But this whole thing of looking at the clock is expensive. It does take some time to execute this function. And we are doing this in the sample block, which is not ideal because it is more work for the sample block, especially when we ask for the time precise, which we are not. We are looking at just time. But still, it gets it's a little more work than just setting a flag. So how about we try this flag idea? Oh, but that's not really gonna work, is it? Because on the block, for instance, we could start challenging the GFX block. So we could say something like GFX running flag is equal to false. So this is setting up the challenge much in the same way that this is setting up a challenge. And then in the GFX block, we could have something like running flag true, which is a response to the challenge. But this is not really going to work all that well because now we have the opposite relationship. This is challenging a lot more often than this can answer. The challenge is posed so fast that this doesn't have the time to really answer because this is only going to run 30 times a second while this is running 48,000 times a second. So it doesn't have time to answer to the challenge. And then the block will think that the GFX block isn't running, while in fact it may be running. So we are going to change this from flag into a counter. And then instead of saying just true, I will say a number like 1,000. And this is going to decrement 1. So now this will run 1,000 times, and then it will be challenging the GFX block. So for every 1,000 runs of the block, we challenge the GFX block. And naturally, the GFX block is answering that challenge over and over every time it runs. This is better. Now, let's come up with a better number here. We know that this number needs to be related to the refresh rate of the screen and related to the number of times that we run the block. And we have a variable for the number of samples in the block. I think it's block samples. No, it's samples block. For instance, my block size is 256 right now, so we see 256 there. So samples block. So if we take samples block and divide by the sample rate, we get a number that is the period of the calls to the block. This is how much time it takes for the block to be called. And then we also have the notion of the refresh rate of the screen. We have that as, how do we have that? I forget how we have that. Refresh rate. Yeah, okay. It's something related to the waveform display in particular right now, but it shouldn't be. It should be a global thing. And now it is a global thing. And I think this is the computation that I want, but let's double check the math here. I have this number is in seconds, and that's how long the block takes to run. No, this is not gonna do the right thing. I could just also come up with like 1,000 and that would be okay. But then if you change the refresh rate or if you change the block size, it could be annoying. So I would have to think about the maximum sampling rate. So something like 192 kilohertz. And then I would have to think about the maximum block size, and it could get complicated. So I think it's better for me to just devise a formula here. And the formula that I want is essentially the rate. How many times is the GFX block going to... No, how many times is the block going to run between two consecutive runs of the GFX block? That's the question. So in other words, what is the rate of the proportion of the two? Well, how many times is the GFX block running? The GFX block is running at the refresh. Yeah, it's running at refresh rate times per second. So like something like 60 hertz is 60 times per second. And I'm having to write all of this down. Maybe I should have a secondary camera here so you can see my notebook, but I'm trying to write things down to think about things because it gets complicated and I always get annoyed by these kinds of computation, these kinds of formulas that I have to come up with. So that's refresh rate times per 1 second. How many times is the GFX, how many times is the block running? Well, I think I have the right formula here, but let's double check. So 48,000 samples, at least in my sampling rate. So S rate corresponds to 1 second. And then samples block corresponds to, okay, so samples block divided by the sampling rate gives me the length of time it takes between two consecutive runs of the block. And this, or I guess 1 divided by this, so this formula here is the amount of time it takes between two consecutive runs of the GFX block. And I am interested in knowing how many times is the block going to run between two consecutive runs of the GFX block. So I think what I need to do is to take this number and divide by that number. Yeah. This is how much time it takes for the GFX block to run. This is how much time it takes for the block to run. If I divide this by that, I have how many runs of the block occurs between two consecutive runs of the GFX block. I think I have this formula right. Let's see if this is a reasonable number. 1 divided by, let's say 30, 256, 48,000. Okay, sounds about right. If let's check this. So this is 6.25. So we are claiming that the block is going to run 6.25 times between two consecutive runs of the GFX block. Let's check if that makes sense. How do I check if that makes sense? Well, I can check that how many samples will be processed by 6.25 runs of my block size. That's 1600. And if I multiply this by 30, it should be 1 second. So it should get me my 48,000. I guess I'm off by 10. Oh, that's because no. I'm off by 10. Oh, it's because I have an extra 0 here. There you go. This all checks out. So this is the right formula. But I cannot guarantee that this is going to run exactly in sync all the time. So I'll have a little bit of leeway, and I'll say that I will have 10 block runs. So the number here will be 10. That means that I can drop some frames. I can drop 10 frames on the GFX block, and still I will be able to answer the question that the challenge posed by the block. So I have a little bit of time, even if some frames are being dropped, I have a little bit of time for the block for the challenge posed by the block to be answered. Yeah, okay, that was complicated and weird, but I think I got it. Maybe we can simplify this formula a little bit, but I really like the way that it reasons about things, so I guess I will keep it. There is some simplification to be done with all these divisions, but it doesn't matter all that much. And many of these actually can be, yeah, this whole formula can be computed just once. So that's what I'm going to do over here. I'll call this reset. And naturally, this can be a fractional number, so I'll just take the ceiling of this whole thing. Now it's an integer, because I'm doing -1, right? So might as well just work with integers. So this is us answering the challenge. And this is us challenging things. And I guess I only want this to occur if it is greater than 0. This way we guarantee that this is a conditional, and I think that conditionals are slower than mathematical operations, so I'll do this some other way. I'll take the maximum between 0 and that -1. I think that this is going to be slightly faster. But the intent is the same. I want this to be 0 or positive. Okay, so now we have the whole setup. Then we have to check. So we want to be able to answer the question, are we about to reset? And this is the previous implementation that we are going to get rid of. So the way we can do that is by just checking if the counter is 0. And over here, we also have a function like is running or something. Yeah, we have that function. We can just change this implementation to check for this. And maybe we can use that there. Then we can get rid of a bunch of things. So this whole GFX time can go away. I think that maybe the waveform display depends on this. No, doesn't seem like it depends on that, so that's fine. Then this we implemented with that. Time current, I think, was only used over here. Okay. And this whole is running situation, I think I will rename to just running. And I don't really like how this has to be a function. So it doesn't really have to be a function, because I'm just checking if it's 0. And 0 is false. So I can just, I can just use that variable directly. So let's see where I'm doing this counter situation. Just rename it to running. And then that. All right, I think we did it. Because then when it's 0, it's false. And then I have to change this calls so that they are no longer calls. If I did everything correctly, then this should just continue to work. Maybe I made a mistake, but let's check. It's no longer working. Great. So let's commit what we have. Oh, and this whole experiment here. Yeah, whatever. I can commit this. And on the waveform display, not much has changed. Great. All these things seem to be correct, so let's go over this whole GFX running situation. Oh, this is not right. It's always resetting. That seems weird. Why is it always 63? If I go to another plugin, running goes to 0. That's great. That means that this part is working. If I go back, then this number continues to always be greater than 0, indicating that the GFX block is running. And this is also 1. Okay, now it's 0. I can bypass. That works. If I go to another plugin, then this should be 0. And it is. So I guess the only question that remains is, why is this always 63? Why does it think that it's always resetting? Oh, okay, that's this variable. That's correct. Let's look at GFX underscore. No, just reset. Okay, it's not resetting. It's 0. Then when I go out and come back in for a brief moment, it should be 1. Just for a brief moment, it should be 1. Okay. So it seems like the whole thing that we implemented is right, but I probably introduced some other bug that is now preventing the drawing of the waveforms. But that's okay by me. Because at least the thing that we proposed to implement, we implemented. It is working. We can detect whether the UI thread is running. We can save some work on the audio thread by checking if the GFX block is running. We can save some work there. And when necessary, we can also reset stuff when the GFX block just started running again. Then we also implemented a way to detect if the audio thread is running or if it's bypassed. And when it's bypassed, we want to reset stuff on the UI thread, or we want to do some other kind of work. And we also did that, and that is working. And we implemented the promised on the title of the stream, this lovely little frames per second count. So that about concludes the work for today. Tomorrow I will be working with Aria on our pitch shifter or something else. But the pitch shifter is working, so now we are probably going to try to implement it on the delay effect that we are working on. The ping pong delay we will add pitch shifting to the ping pong delay, I think. Maybe we will work on something else. So tune in tomorrow for that. I'll be working with Aria on JS effects. And on Wednesday, I will be back to this. And in light of this whole frames per second situation and some other things that I have cooking up, I think that we will potentially improve the smoothness of the waveform display and also figure out what the bug is, why it's no longer showing up. For now, thanks for being here with me. Let me shout out to the people who were active on the chat. So thanks, Bobs, Bo, and Jerome. I hope you found this entertaining, and I hope to see you again here tomorrow for some more JS effects. Have a good one. Bye. Thank you for watching the stream. You know how great it has been.
Or maybe it sucked and I am glad that you stuck with me. And soon we'll be back together for some more coding or talking or chilling. The next time I'll be streaming.